Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for short answer type questions. Let us begin with chapter Ray Optics and Optical Instruments. The first question is, why the setting sun does appear red? So first, you take the external part of the earth. So let us say, so here is the observer. So here is the sun at the origin, you can say. Here is sun. So sun at the origin. Next, so sun nearly overhead here. Let us say sun nearly overhead here. Nearly overhead. Okay, so this is the distance, you can say. Distance of atmosphere through, this is the distance of the atmosphere, through which the sunlight, sunlight travels in the atmosphere. Okay, so let us continue the explanation part. Explanation. So after you, this is Earth. So let us continue the explanation part. Yeah. So when light travels through Earth's atmosphere, it gets scattered. So which means change of direction. Due to atmospheric particles. The light of shorter wavelength, scatters more than the light of longer wavelength. So the blue light, predominates in the clear sky because blue has less wavelength. Compared to red. But even violet has least wavelength compared to blue. But human eye cannot sensitize, cannot be able to observe. human eye is more sensitive to blue than the violet. So the amount of scattering is directly proportional to, is inversely proportional to fourth power of the wavelength. So this is called Rayleigh scattering. So that is why we can see, the sky blue. The sky as blue. At the time of sunset or sunrise, light how to travel larger distances through the atmosphere most of the blue light and other shorter wavelengths light rays get scattered within the atmosphere the only longer wavelength light, so that is red, reaches the eye, therefore sun appears reddish. This explains the reddish appearance of the sun at the time of sunrise and sunset. So let us move to the next question. Second question. Define critical angle. Explain total internal reflection using a neat diagram. So first, critical angle. Okay. When light travels from denser medium to a rarer medium, The angle of incidence in the denser medium for which angle of refraction in the radial medium is 90 degrees. So how to understand this is, so let us say this is the layer separating rarer and denser. Let us say this is rarer medium of refractive index mu1. This is denser medium of refractive index mu2. So let us say object is here. So assume that this is the incident ray. So object in the denser medium. Then in case if you notice that for this angle of incidence, so the regular practice is to take a normal at the point of incidence. Let us say this is a critical angle. In case if you observe that the refracted ray passes along the surface separating the two medium. So therefore, angle of refraction is 90. So this is incident ray, this is refracted ray. So since light is from denser to rarer, so therefore refractive index of denser medium with respect to rarer medium. So it means you can understand that light is from refractive index of rarer medium with respect to denser medium, because light is from second medium to first medium. So this is relative refractive index. So relative refractive index of medium 1 to medium 2. Yeah, so this can also be written as mu1 by mu2. So use Snell's law, sin I by sin R. So treat I itself is the critical angle and sin 90. So refracting angle is 90. Then if rarer medium is air, refractive index of air is equal to 1. So therefore it will be 1 by mu2. So there is no point to write 2 when refractive index of air is taken 1. So mu, this is sin C divided by sin 90 is 1. So this is the relation. So 1 by mu is equal to sin C. So this is the relation between critical angle and the refractive index of the denser medium. In continuation of this, we have a definition of total internal reflection. So the definition is, when light ray travels from denser to rarer, medium at a particular angle of incidence, at a particular angle of incidence in the denser medium, which is greater than critical angle, light reflects back. In the denser medium. So this is called total internal reflection. So with the help of diagram, you can understand that. So once again you draw the layer separating the two medium. So this is rarer with the refractive index mu1. This is a denser with the refractive index mu2. Say object is in denser medium. You can say it's a first trial. So XY is the light ray. You can even write like this. XY is the light ray. Light ray. Incident at point A. Incident at A. So as usual, normal. So when it leaves the denser medium, it goes away from the normal. Take the second trial. When angle of incidence, let us say this is trial 1. Next, for the next trial, angle of incidence is more. So you can say, let us say this is x1, y1, ray x1, y1. x1, y1 makes more angle with the normal bends further away. So let us say this is a refracted ray. So for the second trial, you can make it as this is R1 for I1. You can say this is R2 for I2. Yeah, so you take another trial. First to get critical angle. This is the next trial. So let us say this is a corresponding normal. So I3, you treat I3 is the critical angle where light ray travels along the normal. So therefore you can say I3 is the critical angle. Where the refracted ray travels along the normal. So you take another trial for total internal reflection. Another trial means increasing the angle of incidence further. So therefore you call this as I4. I4 is greater than critical angle. So I4 is greater than critical angle where light reflects back. Into the same denser medium. So this is called as total internal reflection. So what happens here is light bounces back. So therefore this I4 is equal to this I4 under the same denser medium. So this is a refracted ray. This is a reflector. Yeah. Let us discuss the answer for fourth question. So explain the formation of mirage. So this is the consequence of total internal reflection only. So let us say on the ground. So there is a tree like this on the ground. So when a person is here, looks at the tree, the light rays will incident here in front of the person, maybe like this maximum. So this is when air at a uniform temperature. So these are the light rays in general normally. When there is total internal reflection takes place. Suppose once again the same tree. Then, so the layers of air are colder close to the top of the tree. The light ray in general travels like this, like in the curved path due to multi-reflections. So here is the same person. Then it appears like this. This is also called as optical illusion. Yeah. So this is nothing but mirage. So, but how to write the answer?